Good day everyone, my name is Ashelebe Latifat Olanike and here is Ashelebe Latifat Online Academy where we'll be teaching mathematics. So today we want to start with sets. I'm very sure that we are all familiar with the word set, but what is the meaning of set in mathematics? In mathematics, set is the collection of objects, collection of things, collections of shapes, collection of alphabets. So let me quickly write the definition of set. Set is a well-defined collection of distinct objects. Set is a well-defined collection of distinct objects. Objects, things, numbers, and alphabet. So, collections of numbers. If I say natural numbers, set of natural numbers from 1 to 20. So that is the collection of numbers. So collection of vowels, which is A, E, I, O, U. That is collection of alphabets. So set is a well-defined collection of distinct objects, things, numbers, and alphabets. Sets are represented with capital letters. For example, if I say set A, I'm not going to write it as small letter A, so it has to be written as capital letter A. If I say set B, it has to be written as capital letter B. Set X, set Y, set Z, and so on. So all the members of sets are called elements. Members of sets are called elements. And these elements have to be written in small letters. So elements can be written in small letters. For example, if I say set A has to be written in capital letters, so its members, let's say vowels, have to be written in small letters. So A, E, I, O, U. So that's how to write set. Now, identification of set. Sets can be identified if these three properties are followed. The first one is that we have to describe the elements of a set. You have to describe the elements of set. Number 2, by listing the members of set. Last but not least, all these elements to be enclosed in a curly bracket. So by enclosing the elements in a curly bracket. So what's the meaning of these properties is that if you say that set A is consists of prime numbers from 1 to 10, that means you have described what the element of set A must look like. So set A, we say that is consists of set A consists of prime numbers from 1 to 10. So we have described it. So you have to list those numbers. Prime numbers are numbers that consist of two factors, that is 1 and itself. So all the numbers that has just two factors are what we call prime numbers. 1 is not a prime number because 1 consists of just one factor itself alone. So 1 is not a prime number, but 2 is a prime number. 2 has just two factors, 1 and itself. 3 has just two factors, 1 and itself. 5 has just two factors, 1 and itself, and 7 has just, so they are from, these prime numbers are from 1 to 10. So we can get this element inside 1 and 10, between 1 and 10. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. 9 is not a prime number because it has 3 factors, 1, 3, and itself. But those that have 2 factors is what we are talking about here. So we have described the elements of set A. We have listed the elements of set A. So the last one is this bracket. So if you do not put this bracket there, that means we are not talking about sets. We are not describing sets. So this one can be sequenced. So until when we enclose it in a curly bracket, and not just ordinary bracket, not this, not this, not this, not this, but this curly bracket. So all these properties must be followed if we are truly talking about sets. Now let's go to types of sets. We have different types of sets. Number 1 is finite sets. Finite. A set is said to be finite if the number of its elements has limits. That is, it has where it stops. So, for example, let's say we have set A to be equal to 1, 2, 3, 4, 5. So it stops at 5. So it has limit, it has end. So number 2, infinite set. A set is said to be an infinite set if the number of its elements do not have where it stops. So it goes till infinity, indefinite. So if we have, let's say set B is all the numbers, all the natural numbers, we just know where it starts from. It starts from 1, but we do not know where it ends. So we have 2, 3, 4, and so on. So that is an infinite set. Number 3. Unit set. A set is said to be unit if it has just one element. So just one element. So if you write set C, okay, let me put set C. For example, e.g., we have set C to be equal to. So we can see that it just has just one whole number, which is 0. Although 0 is not a natural number, but 0 is an integer, and 0 is a whole number, so it can be counted. So this one is a unit set because it has just one element. So another one, we have D. Let's say D has just one element, 1. If set E has just one element, A, and so on. Those ones are unit sets. So number 4, empty set or null set. A set is said to be an empty set if it doesn't have any element at all, and it is denoted with this symbol or this one. That means it doesn't have any element at all. So after that one, let's go to subset. Sub, this word sub means part of. So if we say that A is a subset of B, it means that set A is part of set. All the elements of set A are part of the elements of set B. That is, we can find some of the elements of set A or all of the elements of set A inside set B. So it's denoted with this symbol. So if you are considering two sets A and B, and we say that A is a subset of B, means that some of the elements of A or all of the elements of A can be found in set B. For example, let's say A is 1, 2, and 3. And B, set B, is 1, 2, 3, 4, and 5. We can see that all the elements in set A can be found in set B. So we can say that set A is a subset of set B. That is, all the elements of set A can be found in set B. So, superset. Number 6. So superset. From this example now, the B that consists of all the elements of set A is now the superset of set B. So B is a superset. So it is this symbol that we use for superset. That is, B consists of all the elements of set A or some of the elements of set A. So B consists of all the elements or some of the elements of set A. So after that one, let's go to cardinality of set. Cardinality of set is the number of elements in a given set. So for example, that is numbers of elements, or number of elements in a given set. For example, let's take set P to be A, B, C, D, E. The number of elements in this set P is what we call, okay, let me use Y so that it will not confuse us. So the number of elements inside this set Y is what we want to talk about now. That is, we need to count it. This is number 1, number 2, number 3, number 4, and this is number 5. So how many elements do we have inside sets Y is what the cardinality of set is talking about. So, and it can be denoted like this. That is, the number of elements in Y is equal to what? Count it. 1, 2, 3, 4, 5 is equal to 5. So the number of elements in a given set is its cardinality. So after that one, let's go to power set. This power set is a set of all the subsets of a given set. The set of all the subsets of a given set. One set which definitely have some subsets. So the set of those subsets is what we know as power set. That is the set of all the subsets of a given set. Is what we know as power set. For example, if we have set X to be equal to 1, 2, and 3. Some parts of the set, another set that we can easily find inside the set is what we want to talk about now. So definitely we can get empty sets inside this one. We can find 1 inside it. We can find 2 inside it. We can find 3 inside it. We can find 4 inside it. We can find 1 and 2 inside it. We can find 1 and 3 inside it. We can find 2 and 3 inside it. And we can find 1, 2, 3 inside this given set X. So all the set of these subsets is now what we know as power of set X. So it has to be enclosed in another curly bracket. So the set of all the subsets of set X is what we are talking about. 1, 2, 3, 4, 5, 6, 7, 8. So if you quickly want to know its cardinality, if you quickly want to know the number that it's supposed to have. So now talk of cardinality of power of set X. So with this formula, we can easily get it 2 raised to the power n, where n is the cardinality of the given set X. And the cardinality what? Cardinality of x is what? Is 3. That means n is equal to 3. So if you want to know the cardinality of power set of set x, it's going to be 2 raised to power 3, which is equal to 8. So the number of all the subsets of set x is equal to 8. That is the meaning. So let's quickly do another example. Under power set. Example 2 under power set. Let's call this one example 1. So example 2 under power set. Let's say we have y to be equal to 1, 2, 3, 4, 5. You know, if you want to list the power of y, it can give us some tough time. So empty is number 1, then 1, 2, 3, 4, and so on. So it will take time. So, but if they want in what they wanted to tell us the number of the subset, so you can quickly say that it is 2 raised to power n. What is n here? 1, 2, 3, 4, 5. And 2 raised to power 5 is equal to what? Is equal to 32. So if you still want to list it, all the subsets of power, all the subsets of sets y must be, the numbers must be 32. So we want to list it, we list empty 1, 2, 3, 4, 5, then we'll be combining them together. So, but at the end of the day, we must have 32 elements inside the power of set y. So that's about power set. So number 9, let's talk about universal set. This one is V, universal set. Now, it's very, very important for us to understand the meaning of universal sets, because it is the set that consists of all the elements under consideration. A set is said to be universal set if it consists of all the elements we want to talk about, all the elements we want to work on, all the elements under consideration. So universal set is any set that consists of all the elements under consideration. Set that consists of all, very, very important, all the elements under consideration. For example, if we say set A is equal to, universal set is denoted with this symbol, or write it like this. So e.g., we have our universal set to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have set A to be equal to 2, 5, 7, 9. We have set B to be equal to 1, 2, 3, 4, 5, 6, 7. So we can see that we can easily find this set A inside the universal set. We can find set B in the universal set. The meaning is that set A is a subset of universal set, and set B is also a subset of universal set. So universal set consists of all the elements that we want to talk about here. So that is the definition of universal set. So before we end this lesson, so let's quickly do it yourself, DIY. So state whether number 1, the following, state whether the following sets are equal or not. A is equal to 1, 2, 3, and B is equal to 3, 2, 1. B, X is equal to A, E, I, O, U, and Y is equal to U, E, A, I, O, and C, the same, Z is equal to 1, 2, 3, 5, 7, and we have 1, 2, 3, 4, 5, 7. So state whether they are equal or not. Then another one. Let's do example exercise on cardinality, algebra, and power sets. So number 2, what is the cardinality of x? So let's say we have x to be equal to 1, 2, 5, 8, 9, 10. So find this one. So let's stop there. So please, if you find this video useful, subscribe, comment, and like. Thank you till I see you in the next video.